Students, next coming to the chemical properties of group 17 element. As you already know, group 17 elements are generally called as halogens. There we have fluorine, chlorine, bromine, iodine and astatine. So coming to the chemical properties, we have first one, that is oxidation state. Oxidation state. So under oxidation state, actually all halogens exhibit -1 oxidation state. Okay, now so the general oxidation state, that is halogens exhibit -1 oxidation state. Okay, now and even here we have chlorine, bromine and iodine, which also exhibits +1, +3, +5 and +7 oxidation state due to presence of vacant orbitals in their valence shells. Okay na, so vacant orbitals irodrinda even these elements, that is chlorine, bromine, iodine, exhibit +1, +3, +5 and +7 oxidation state. Next, the chlorine, bromine, iodine are formed by the higher oxidation state when halogens are combined with a small and highly electronegative ಫ್ಲೋರಿನ್ ಆರ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್. ಸೊ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಅಥವಾ ಫ್ಲೋರಿನ್ ಆಟಮ್ ಜೊತೆಗೆ ಏನಾಗಿರುತ್ತೆ, ಕಂಬೈನ್ ಆಗಿ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್. ಸೊ ದೋಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಇಂಟರ್ ಹ್ಯಾಲೋಜನ್ ಕಾಂಪೌಂಡ್ಸ್. ಓಕೆನಾ, ಸೊ ಇಂಟರ್ ಹ್ಯಾಲೋಜನ್ ಕಾಂಪೌಂಡ್ಸ್. What do you mean by interhalogens? The halogens reacts with itself to form a compound. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫ್ಲೋರಿನ್ ಮತ್ತು ಕ್ಲೋರಿನ್ ಎರಡು ರಿಯಾಕ್ಟ್ ಆಗಿ ನಮಗೆ ಕ್ಲೋರಿನ್ ClF2, ClF3, ಕ್ಲೋರೋಫ್ಲೋರಿನ್ ಆ ರೀತಿ. ಓಕೆನಾ, ಆ ರೀತಿ ನಮಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಸೇಮ್ ಎರಡು ಹ್ಯಾಲೋಜನ್ಸು ಅಟ್ಯಾಚ್ ಆಗಿ ಆಗಿರ್ತಕ್ಕಂಥ ಕಾಂಪೌಂಡ್ಸ್ನ. ಸೊ ದೇರ್ ಈವನ್ ದಿಸ್ chlorine, bromine, iodine, so they will react with the fluorine or oxygen atom in their higher oxidation state. Okay, now next, chlorine and bromine exhibit chlorine and bromine exhibits +4 and +6 oxidation state in terms of oxides and oxoacids. Okay, now oxides and oxoacid formally ನಮಗೆ ಏನಾಗಿರುತ್ತೆ, ಕ್ಲೋರಿನ್ ಆ್ಯಂಡ್ ಬ್ರೋಮಿನ್ ಎಕ್ಸಿಬಿಟ್ಸ್ +4 and +6 oxidation state. Here fluorine exhibits only -1 oxidation state, that is due to the absence of d orbital. Okay na, so due to absence of d orbital, fluorine exhibits only -1 oxidation state. Okay na, the overall or general oxidation state is -1 only. So here chlorine, bromine, iodine exhibits variable oxidation states. Particularly we have fluorine, which exhibits only -1 oxidation state, that is due to the absence of d orbital. Nextly we have oxidation property. Oxidation property. Basically these halogens are good oxidizing agents. Okay na, so halogens ಎಲ್ಲ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ those are good oxidizing agent. How they behave means they gain easily electrons to form halide ions. Okay na, halogen ಇರೋದು electronsನ gain ಮಾಡಿಕೊಂಡು it will form halide ion. So halogens are good oxidizing agent. The order of this oxidizing property, that is fluorine, which is greater than chlorine, further greater than bromine and iodine. Okay na, so the order is like this. Commonly these halogens oxidize halide ions of their higher atomic number. Okay na, means next higher atomic number ಇರ್ತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆಗೆ it will form oxidize, it undergo oxidation and it will form halide ions. Okay na, so that is example, fluorine combines with halogen to form F- plus X2. Here X refers to chlorine, bromine and iodine. Okay na, X equals chlorine, bromine and iodine. ಅಂದರೆ ಹೈಯರ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಇರೋಂಥದ್ದನ್ನು ಅಂತಂದ್ರ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿಸಿದಾಗ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಎ ಹ್ಯಾಲೈಡ್ ಅಯಾನ್ಸ್. ಓಕೆನಾ, ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ ಏನಿದೆ ಅದು ನಮಗೆ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಎ ಹ್ಯಾಲೈಡ್ ಅಯಾನ್. ದೆನ್ ವಿ ಹ್ಯಾವ್ ಕ್ಲೋರಿನ್, ದಟ್ ಈಸ್ combines with this, and here 2Cl minus plus X2. Here halogen is equal to chlorine. Chlorine next do bandre namige that is bromine and iodine. Higher atomic number irtakanta halogens. Similarly, we have bromine that combines with iodine to form Br minus plus I2. Okay na? So like this we have different halogens which oxidize halide ions of higher atomic number. The oxidation property of halogens in the aqueous solution depend on the standard electrode potential. We have a standard electrode potential. So based on that, this oxidizing property of halogen depends. Then fluorine oxidizes water to oxygen. Okay, now fluorine oxidizes water to oxygen under highly exothermic condition. Okay, now so fluorine oxidizes water to oxygen. Similarly, chlorine dissolves in water to form hydrochloric acid and hypochlorous acid. Okay, na? Hydrochloric acid and hypochlorous acid. This one is hypochlorous acid, HOCl, hypochlorous acid. It is one of the oxo acid of chlorine. Okay, na? So, here this water is called as chlorine water. Okay, now the combination we call it as chlorine water. Then bromine reacts with water to form HBr and HOBr, that is hypobromous acid. Okay na? HBr, hydrogen bromide. Then iodine does not react with water because it is a non-spontaneous reaction. Okay na? So particularly I minus ion easily oxidizes acidic medium to form iodine. ಓಕೆನಾ. ಸೊ ಇದು ನಿಮಗೆ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಅಂತಂದರೆ ಡೈರೆಕ್ಟಾಗಿ ನಮಗೆ ಅಯೋಡಿನು ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ದಟ್ ರಿಯಾಕ್ಷನ್ ಈಸ್ ಹೈಲಿ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್. ಹೆನ್ಸ್ ಇಟ್ ಅಯೋನೈಸಸ್, ಐ ಮೀನ್ ಟು ಸೇ ಇಟ್ ಆಕ್ಸಿಡೈಸಸ್ iodide ion oxidizes in acidic media to form iodine, that is I minus ion. In presence of acidic media, that is H plus, it undergo oxidation to form iodine. Okay na. So this is about the oxidizing nature of halogens. So next we have reactivity towards hydrogen. How these halogens reacts towards hydrogen. So usually halogen reacts with hydrogen to give respective hydrogen halides. Okay na. So hydrogen halides formation agutte, but the affinity for hydrogen decreases from fluorine to iodine. Okay na. Means the affinity towards reaction with hydrogen, it decreases down the group. Okay na. So it will form respective hydrogen halides. That is nothing but HX. Okay na. Hydrogen halides. Then hydrogen halides which dissolve in water to form hydrohalic acid, which dissolves in water to form hydrohalic acids. Then the order of strength of these acids, that is hydrogen fluoride, which is less than HCl, which is further less than HBr, then HI. So hydrogen halides ಏನಿದೆ ಅದರದ್ದು ಆರ್ಡರ್ ಆಫ್ ಸ್ಟ್ರೆಂತ್, ಐ ಮೀನ್ ಅಸಿಡಿಕ್ ಸ್ಟ್ರೆಂತ್ ಈ ರೀತಿ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ HF ಲೆಸ್ ದ್ಯಾನ್ HCl, ಫರ್ದರ್ ಲೆಸ್ ದ್ಯಾನ್ HBr ಆ್ಯಂಡ್ HI. Then the order of stability. So stability order, that is HF greater than HCl, further greater than HBr, which is further greater than HI. Okay na. So the stability order is like this. Then reactivity towards oxygen. Reactivity towards oxygen. So these halogens reacts with oxygen to form particularly two type of oxides, that is OF2 and O2F2. Okay na. It will form two type of oxides, that is OF2 and O2F2, and it is stable at 298 Kelvin. So thermally stable at 298 Kelvin. These oxygen fluorides are strong fluorinating agents. Okay, na? Particularly these are strong fluorinating agent. Fluorinating agent. So particularly this O2F2 oxidizes plutonium to PuF6, and the reaction is used in removing plutonium as PuF6 from spent nuclear fuel. Okay na? So nuclear fuel ಆ ಒಂದು ಕಾನ್ಸೆಪ್ಟಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ particularly this O2F2 that oxidizes plutonium to PuF6. Okay na? Then chlorine, bromine and iodine form oxides in which the oxidation states of these halogens are +1 to +7. Okay na? So chlorine ಮತ್ತೆ bromine and iodine. Chlorine, bromine and iodine form oxides only in +1 to +7 oxidation state. The order of stability of oxides, that is order of stability of oxides, that is in terms of halogens, that is I greater than Cl, further greater than Br. So these oxides of chlorine are stable, that is due to formation of multiple bonds with oxygen due to presence of d orbitals. Okay na? So d orbital involve agirodrinda we have multiple bonds with oxygen, hence oxides of chlorine are more stable. Then chlorine oxides, that is Cl2O, ClO2, Cl2O6 and Cl2O7 are highly reactive oxidizing agents. Okay na? That is Cl2O, ClO2, Cl2O6 and Cl2O7 are good oxidizing agents, that is oxides of chlorine. Clear? Cl2O, ClO2, Cl2O6 and Cl2O7 are good oxidizing agent. Next we have oxides of bromine, that is Br2O, BrO2 and BrO3. So these are less stable and exist only at low temperature. Less stable oxides and exist at low temperature. Okay na? So the stability is very low, and even these also acts as a good oxidizing agents. Then we have oxides of iodine, that is I2O4, I2O5 and I2O7. So these are the oxides of iodine which are insoluble solids, and these easily decompose on heating. Okay na? Insoluble solids and easily decomposes on heating. So heat ಮಾಡಿದಾಗ ಈಸಿಯಾಗಿ ಡಿಕಂಪೋಸ್ ಆಗುತ್ತೆ. Then particularly this I2O5, it is a good oxidizing agent and it is used in the estimation of carbon monoxide. Only this I2O5, it acts as a good oxidizing agent and it is used in the estimation of carbon monoxide. So this is about the reactivity towards oxygen. So halogen reacts with oxygen to form respective oxides. So the different oxides of chlorine, bromine and iodine are like this. Okay. So next we have reaction with metals. Reaction with metals. How these halogens react towards metal. So particularly these halogens or these metals reacts with halogens to form respectively the metal halides. Okay na? Metal halides anta heli heltivi, that is the general representation is Mx. When a metal reacts with halogen, it will form metal halides. So the ionic character of these metal halides are, that is metal fluoride, that is greater than metal chloride, further greater than metal bromide and further greater than metal iodide. So particularly here M refers to metal, that is particularly monovalent metal. Okay na? So monovalent metals reacts with different halogens to form respective metal halides. So these halogens are covalent compounds with a higher oxidation state than lower. Okay na, so these are covalent compounds. Covalent compounds, so which are having higher oxidation state than that of lower oxidation state. That is, we have example SnCl4, PbCl4, SbCl5, UF6 are more covalent than SnCl2, PbCl2, then SbCl3, then UF4. Okay na, so here we have two different types of metal halides. So ಇಲ್ಲಿ ಇರೋದೆಲ್ಲವೂ ನಮಗೆ ಏನಾಗಿರುತ್ತೆ, ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇದೆ, ದೆನ್ ದೀಸ್ ಆರ್ ಲೋಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಸೊ ಹಾಗಾಗಿ ಏನು ಅಂತಂದರೆ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರ್ತಕ್ಕಂಥ ಮೆಟಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಆರ್ ಮೋರ್ ಕೋವಲೆಂಟ್ ದ್ಯಾನ್ ದಿ ಲೋಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರ್ತಕ್ಕಂಥ ಮೆಟಲ್ ಹ್ಯಾಲೈಡ್ಸ್. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ರಿಯಾಕ್ಟಿವಿಟಿ ಟುವರ್ಡ್ಸ್ metal. So next, coming to the anomalous behavior of fluorine. Okay na, so in the group 17 elements we have first element fluorine, which shows anomalous behavior, that is due to its small size, high electronegativity, low bond dissociation energy, and absence of d orbital, okay na. So due to this nature, this fluorine exhibits anomalous property. So now coming to which are those anomalous property. So first one, fluorine is highly reactive due to its lower bond dissociation energy. Okay, fluorine is highly reactive because its bond dissociation is low. So bond dissociation low iradrinda easy agi idu bega highly reactive agirutte. Okay na. Then this fluorine exhibits -1 oxidation state due to absence of d orbital, in its valence shell, whereas others exhibits +1, +3 and +5 and +7 oxidation state. Okay na. Fluorine exhibits only -1 oxidation state, that is due to absence of d orbital, whereas other exhibits +1, +3, +5 and +7 oxidation state. Then ionization enthalpy, electronegativity and electrode potential. Okay na. So these are higher for fluorine than other halogens. Okay na. So ionization energy, electronegativity, electrode potential values ಎಲ್ಲವೂ ಫ್ಲೂರಿನಿಗೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ comparatively to other halogens. Then even ionic and covalent radius, melting point, boiling point and bond dissociation enthalpy, that is FF dissociation enthalpy, then electron gain enthalpy, these are lower than other halogens. Okay na, are lower for fluorine. Clear? Ionization enthalpy, electronegativity, electrode potential are higher to fluorine, whereas ionic and covalent radii, melting point, boiling point, then bond dissociation energy of fluorine and electronegativity, electron gain enthalpy are lower for fluorine. Then many fluorine reactions are exothermic in nature. Okay na, exothermic in nature, that is due to the formation of strong bond with the other elements. Okay na. So ಬೇರೆ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆ ಕಂಬೈನ್ ಮಾಡಿದಾಗ ನಮಗೆ ಏನಾಗುತ್ತೆ, there will be a formation of strong bond. Clear? Means a particular element with respect to fluorine. So ಹಾಗಾಗಿ highly exothermic in nature. Then fluorine forms only one oxo acid. Okay na. Fluorine exhibits only one oxo acids, whereas remaining elements exhibits more than one oxo acids. Okay na. So fluorine exhibits only one oxo acids, whereas other elements other elements exhibits number of oxo acids. Okay na, ಜಾಸ್ತಿ number of oxo acids exhibit ಮಾಡುತ್ತೆ, that is bromine, chlorine, iodine. Then lastly we have hydrogen fluoride, that is a liquid. Hydrogen fluoride, that is a liquid, whereas other halides are gases. Okay na, so other halides, that is HCl, HBr, HI. So ಇವೆಲ್ಲವೂ ನಮಗೇನು gases. Okay na, why hydrogen fluoride is liquid? Because it is having a strong hydrogen bond. So as we already know, hydrogen bond is nothing but bonding with the hydrogen to highly electronegative element. So fluorine is a electronegative element, hence there is a presence of hydrogen bonding in hydrogen fluoride, hence it is a liquid, whereas other hydrogen halides are gases. Okay na, so this is about the anomalous behavior of fluorine. So fluorine is highly reactive. Fluorine exhibits -1 oxidation state, that is due to absence of d orbital, whereas other elements exhibits +1, +3, +5, +7. Then the values of ionization enthalpy, electronegativity, electrode potential are higher for fluorine, whereas remaining halogens are having lower values. Then ionic and covalent radii, melting point, boiling point, and bond dissociation energy of fluorine, electron gain enthalpy value are lower for fluorine, whereas other halogens are having higher values. Then particularly this fluorine related reactions are highly exothermic in nature. Then fluorine exhibits only one oxo acids, whereas other elements exhibits number of oxo acids. Then hydrogen fluoride, that is particularly a liquid, that is due to presence of hydrogen bonding, whereas other hydrogen halides such as hydrogen chloride, hydrogen bromide, and hydrogen iodide are gases. Clear? So this is about the general introduction related to group 17 elements. So next we have compounds under group 17 elements.